Have you ever wondered how computers measure 3D space in medical imaging or video games? My name is Tabitha Floss, and for my honors program project at Wake Technical Community College, I explored how basic calculus is used to estimate 3D volume with voxels. A voxel is like a 3D pixel. It's a cube that represents a small part of space. When arranged in a grid, these cubes form a complex object. Each voxel has an X, Y, and Z coordinate in a 3D Cartesian system, making it possible to simulate and measure real-world volume in digital environments. The idea of voxels dates back to the early days of digital imaging and simulation. One of the earliest projects on voxels dates back to the 1970s, when Edwin Catmull developed the first voxel-based engine at the New York Institute of Technology. The gaming industry has developed various voxel simulation games from Minecraft and Roblox to 7 Days to Die and Blade Runner. Voxel grids became essential in geography, medical imaging, and other digital modeling fields, allowing us to model and measure 3D space digitally and accurately. A voxel is a unit cube in a 3D coordinate system. We generally use the Cartesian coordinate system, which just specifies that each point on a graph has specific coordinates. Unlike 2D pixels that only store height and width, voxels also have depth, making them useful for modeling 3D space. Each voxel has an X, Y, and Z coordinate, forming a structure that we can manipulate and measure. Before calculating the volume of a full model using voxels, we need to know the resolution, defined by the side length S of each voxel cube. Smaller values of S result in smaller cubes and higher resolution models, capturing finer details and producing accurate volume estimates. As S approaches 0, the voxel-based approximation converges to the object's true volume. On the other hand, increasing S also increases the size of the cubes and lowers resolution, reducing accuracy and missing curves or cavities. The total volume can be loosely estimated with the resolution. To calculate the volume of an object in a voxel model, we count the filled cubes and multiply by each cube's volume. This process is similar to using Riemann sums in calculus, which is approximating a shape by adding up small units. The smaller the voxels, the more accurate the Riemann estimation becomes. There are algorithms that can smooth cubes to make the approximation more accurate. One example is the marching cubes algorithm, which takes the cubes that are partially outside of the shape and bevels them so that they fit the shape better. Voxels are used in medicine, geology, and gaming. They allow for precise digital representations of real-world shapes, enabling design, measurement, and simulation across various industries. For example, in medicine, bodily structures can be measured to determine health. In geology, voxels can provide other data such as temperature or soil composition. In gaming, low-resolution voxel builds have provided us with timeless stories. Other applications include determining nitrate concentration in soil and measuring advertising visibility.